Okay. Very good afternoon to all. On behalf of the Department of Artificial Intelligence and Data Science, I, Mrs. Sheila James Maladpure, welcome you all for this one-week online faculty development program on empowering educators' advancement in computing pedagogy, organized by Artificial Intelligence and Data Science Department, VIT Pune. Today's session is on exploring retrieval augmented generation in generative AI, presented by Mr. Prathmesh Palande. It's a great pleasure for me to introduce today's speaker. Mr. Prathmesh Palande is a software development and machine learning engineer. He is a co-founder of one-year-old education technology startup called Adalect. Additionally, he worked at a software services company known as Fresh Gravity. Prior to his current role, he gained experience working with companies such as UBS and MasterCard. Prathamesh holds a Bachelor in Computer Science Engineering from Vishwakarma Institute of Technology, Pune. He pursued as Executive Master in Artificial Intelligence and Machine Learning from Liverpool John Moores University, UK. And he is on track to complete his Executive MBA from Liverpool Business School in the next 6 months. Welcome, Mr. Prathamesh Palande. So we are excited to hear your session. So I would like to request Mr. Prathmesh to take charge of the session. Thank you all.
Hello, everybody. Thank you so much. Thank you, Sheila ma'am, for introducing me. All right, I'll quickly share my screen and I'll quickly ask, is my screen visible?
Yes.
All right, and I am visible too.
Yes.
All right, perfect. Thank you. So, hello, everybody. I am sure I was introduced brilliantly just now. But again, I'm Prathmesh Rajesh Palande, MS in AI and ML, along with a BTech degree in Computer Science Engineering. Today, we'll be looking at and exploring retrieval augmented generation in the field of generative AI. A little bit about my background. I am a co-founder at Adlect. It's an innovative edtech startup. At Adlect, we redefine education by the use of cutting-edge AI to enhance learning, testing, and evaluation processes. I'm also a consultant in data science and analytics at Fresh Gravity, a software services early establishment. Additionally, I will be completing my executive MBA in the coming 6 months. All right, let's look at what all we are going to explore today. Perfect. Coming to the session overview today, we'll be looking at a series of topics beginning from zero with some theory, going up to being a hero, where we all will actually implement a micro RAG system or retrieval augmented generation system to query our India's latest 2024 interim budget, along with looking at an example where we'll be querying one of the latest research papers that has been published. I think it's 12th today. I think it was published yesterday, or it might be published today as well. Or as any request from audience, we can pick up literally anything that is latest, and we can demo that in the system that we'll be having at the end of the session today. To make things interesting, essentially, we would want to pick up any random PDF, any random thing that the audience wants, and then we can do that. Okay. Okay.
Prathmesh sir, please unmute yourself.
Yeah. There was some disturbance in between.
Yes, Prathmesh, sir. Sorry for the disturbance. You can now carry on.
Okay, cool.
Yeah.
Thank you. Cool. So that was a good break. Actually, I was about to say I'll take a break here, short break. And if um, folks are excited for this session, if folks are excited to see a live RAG system working by the end of this session, can I have like a bunch of yeses in the chat? I'm just trying to keep this interactive as much as possible so that after a good lunch that we have had today, honestly, I have had a good lunch. We won't be sleepy in that case. Cool. I do see a bunch of yeses here. Thank you so much. That gives me a good booster for this session, right? Right. So to elaborate over the session overview, we'll be starting from exploring traditional neural networks versus the transformer model. Subsequently, we will look at the transformer architecture. What are the different parts of it? What is the encoder? What is the decoder? What does self-attention mechanism mean? What are embeddings? And so on. Then we'll move on to looking at the buzzword that we have today, right? Generative AI. We'll understand what generative AI is at its core. We'll look at a few examples of common prompts and their respective outputs. We'll also touch base on token limits. And furthermore, we'll look at what limitations do current large language models encounter, which are essentially the backbone of generative AI, right? We'll also take a look at the famous hallucination examples that we all have been listening to, right? I'm sure like LLMs, ChatGPT hallucinates. So what does that mean? Right. So next we will look at what retrieval augmented generation means, which is the real masala per se of this session, right? And why do we need that? In this, we will look at the RAG architecture. What does the retriever mean? What does the generator mean? What does the context mean? We will then have a look at how RAG fits into the bigger picture, how RAG fits into the bigger picture. Following which, we will take a closer look at the various applications and use cases of RAG. And this is the part that's going to be the most interesting, where we'll be building our own micro RAG system. And this is all going to happen in 2 hours. I'm not asking any one of you to stay even a minute longer than 2 hours, right? So I'm going to try to make this as simple for implementation as possible by using one of the latest libraries that we have available from the plethora of libraries that there are for this framework, right? For this specific architecture. Of course, throughout these 2 hours, we will have 1 or 2 short breaks and a handful of quiz questions just to make things interesting. As I mentioned, a nice, good lunch. Cool. Moving on. Let's dive right into our first topic. Traditional neural networks versus transformers. On June 12th, 2017, the research team at Google, called Google Brain, released a research paper called Attention is All You Need, which proposed the transformer model. The peculiarity of this model or this architecture was that it could capture very long sequences of text. We all know RNNs have this big famous problem, vanishing exploding gradients, right? The longer the sequence of our RNN or the recurrent neural network is, the more the problems we have with vanishing or exploding gradients, and the longer we take to find the global minima, yada, 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 right? So in this case, this architecture proposed to near about solve that problem, right? And it, in theory, can handle infinite lengths of sequences. On the other hand, as I mentioned, traditional neural network architectures like recurrent neural networks, long short-term memory networks, gated recurrent units suffer from a great deal of exploding and vanishing gradient problem when the sequence gets a bit too large. The traditional neural network architecture sequence is like they are sequential in nature, and hence they are not really parallelizable, right? If I said that word correctly. Yeah, I practiced saying that word twice or thrice. Cool. So again, coming back to the transformer architecture, right? It neither relies on recurrence nor convolutions, and hence operates on positional encodings, because now there's no recurrence, there's no convolution. Where will the positions come from? They'll come from the positional encodings, along with multi-headed self-attention mechanism. Right? This might be sounding a little bit too heavy, not too heavy, no idea, right? But as we go along, we will dig deeper into what each of these individual pieces mean, and eventually we'll get through the RAG system that we are talking about. Cool. Moving on, let's take a high level view at the transformer architecture, right? While this diagram might look a little daunting at first, let's break it down into smaller components, right, for better understanding. If we look at what's on the left-hand side, right, it's the encoder side of the entire architecture. The encoder side, as you can see, the NX is composed of a stack of 6, for example. In the original paper, they had taken 6. Over here, you can essentially have as many as you want. Each layer has 2 sub-layers, as we can see here, right? How do I use the laser pointer? Okay, cool. Folks can see my laser pointer. In the chat, we have a few messages. Okay, cool. So this was the NX part of I was talking about, right? The stack of identical layers, right? And what is composed inside that layer? Each layer has 2 sub-layers, right? The first is a multi-headed self-attention mechanism that we can see here.
So, zero learning, one app is there. That is a database, statistical database. They're offering programs and various things. So I've spoken to the same person. He's coming tomorrow to explain whole of the process.
Are we good, ma'am? Are we good, ma'am?
Yes, sir.
Okay, cool. Thank you. Maybe the space bar button, right? We all can be a little careful about the space bar, because if you by mistake tap that, it might unmute yourself. And if you're in a mix of something, then cool. Thank you. Well, right. Each layer has 2 sub-layers, right? The first is a multi-headed self-attention mechanism. And the second, which we can see here, is a simple position-wise, fully connected feed-forward network. There is a residual connection around each of the 2 sub-layers, followed by layer normalization for each of them. So there's this residual connection that comes in, followed by the layer normalization that happens for both the sub-layers inside that layer. The output of each sublayer, hence, is the output that comes out of the layer normalization on the original input and the raw output of the sublayer itself, because of the residual connection. The actual input and the output of the sublayer is essentially considered the output of that um, each of the sublayer, right? While if we take a look at the right-hand side, right, we can see the decoder side of the entire architecture. It is a little tricky to go over this at a very high level. I've tried to keep it as precise as possible and concise. So bear with me while we go through this, right? While if we take a look at the right-hand side, we can see the decoder side of the entire architecture. The decoder is also composed of a stack of n such identical layers, right, that we can see here. In addition to the two sub-layers that we have on the encoder side, in addition to those, the decoder inserts a third sublayer which performs the multi-head attention over the output of the encoder stack, which is this encoder stacks feeds into this additional sublayer that does this job, right? And which is essentially again followed by the layer normalization layer. One difference on the decoder side, however, right, one key difference on the decoder side is that the self-attention in the sublayer inside the decoder stack is modified to prevent positions from attending subsequent positions, because we don't want the decoder to know what comes ahead of the sequence. That would be called cheating, essentially, in training, right? So especially the decoder has the mask that we call. It's famously known as the attention mask. That's essentially to mask the rest of the words that are not supposed to be seen, right? In a nutshell, the task of the encoder on the left-hand side, and it is to map an input sequence to a sequence of continuous representations, which is then fed into a decoder. The decoder, on the other hand, on the right half of the architecture that we can see, receives the output of the encoder together with the decoder output at the previous step to generate an output sequence, right? As quoted down here, I've written as quoted in the original paper. At each step, the model is an auto-regressive consuming the previously generated symbols as additional input when generating the next symbol. Essentially, generative AI works on the architecture, or transformer works on the architecture, given a bunch of words, given a sequence of words. My name is Prathmesh and I like to play, given this sequence of words. The large language model will try to predict the next word or the next n words. In my case, it will say I like to play badminton and a lot of video games, maybe. Cool. So moving on, what is scaled dot product attention, right? The buzzword self-attention, what does it exactly mean? What is the meaning of self-attention? Because every one of us always, from like the engineering background, every one of us always thinks of everything that I should understand what exactly attention means. So let's have a look at what that means, right? Because calling just self-attention is like super cool, but then what exactly is inside that, right? So the input consists of queries and keys of dimensions dk, right? Now, in a sense, if we try to compare key, query, and value with the analogy of databases, we can say the query is our database query, right? SQL query, something like that. The key is the index, or the data that we have. Those are the keys that we have. And the value is the result of our query. Now, attention mechanism works on this exact same principle, where it multiplies query with the key, scales it appropriately, because in deep learning, machine learning, nothing goes without scaling, right? And then you apply a softmax layer to distribute the probabilities across the input query and the other respective keys, which is essentially trying to compute the importance, the relative importance of the current word with respect to all the other words. While I am saying this, you can look at the example on the right hand side so that you get a feel of what the example relates to while I say this, right? And then eventually we multiply this distribution of softmax with the original value. And that the resultant of that is the attention number or a single output, right? Word vector representation of that particular word, which is essentially what we call attention. So you have a sentence, maybe we can read this out together. I like natural language processing a lot. Walking through an example of all right. Is it better now? Is there any disturbance from my side?
No, sir.
Okay. There is disturbance on my side. So is it coming through the mic? It's not, right?
No,
No,
sir.
sir.
It's all.
All right. Thank you. Walking through the first example, word I, right? The query is the input vector for the token I, let's say. The keys are the output, the keys are the input word vectors for all the other words in the sentence, right? And for the query word too, that is like natural processing, blah, 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 right? So keys are essentially all the other words and also the query word. The word vector of query is then the dot producted with the word vectors of each of the keys to get 9 scalars, also called weights or the importance. So multiplying the query with the key is a list and query is just one, right? Uh, we essentially get a vector of weights, right? Those weights are then scaled. Scaling again, not important for intuition, but um, scaling happens just everywhere in machine learning. The weights then go through the softmax, which is a particular way of normalizing the 9 weights to values between 0 to 1, essentially trying to find out the distribution. This becomes important to get a weighted average of the value vectors, which we see in the next step. Finally, the 9 input word vectors or values are summoned in a weighted average. So now this output vector of softmax is essentially, if I want to quickly write, this output vector of softmax is going to be the same length as the value vector. So now this is going to get multiplied by a weighted average, right? I see a hand raised. Maybe I can pause for a moment. Tell me. All right. Maybe I can continue. Cool. All right. Let's now then move on to the next slide, right? This was one slide that we spent a lot of time on, surely. But to my opinion, it was imperative to understand what attention mechanism means, right? Now also let us look at what is multi-headed attention. Essentially, instead of performing a single attention function with D-model dimensional keys, values, and queries, it is found beneficial to linearly project the queries, keys, and values each times with different learned linear projections to DK. That is, if one head can have one sort of learning, if you have parallel heads, why we call transformers or parallelizable is because if you add such H heads, right, you're making projections of the exact same input, right? But they are learning different things. And therefore, you're getting a broader spectrum of learning. And this yields dV dimensional output values. These are concatenated and once again projected. resulting in the final values as depicted in the figure on the left-hand side, that we can see the final multi-head values are linear, right? They are again projected down or concatenated, as we can see there. With a single head, right. So in simple words, right, multi-head attention is a type of attention mechanism that uses multiple mechanisms to control how it consumes information from an input sequence. It allows the neural network to control the mixing of information between pieces of input sequence. Why? Because there is parallelizability in the same input sequence. This leads to the creation of richer representations, which in turn allows for increased performance on machine learning tasks. So when Google Brains team came up with this attention all you need paper, they also came up with this multi-headed parallelizability to that. Perfect. Moving on. What is generative AI? Finally, we are here, right? With all that said about transformers. In a sense, transformers and generative AI go well hand in hand. It is nothing but a sequence of words. The task, given a sequence of words, the task is to predict the next word or the next n words. Apart from transformers, other models like generative adversarial networks, or popularly known as GANs, we also then have autoencoders, under which we also have variational autoencoders. If we touch base on reinforcement learning models, we also have the Markovian models in play. Right, so that's all about it. Generative AI is given a sequence of words, predict the next word or the next n words, right? So let's have a look at a few examples of like very common generic examples, right? That me and you every day in and day out use while we are using ChatGPT, right? For example, in a world where technology has surpassed human capabilities, a lonely inventor creates, and then ChatGPT says, a sentient AI companion capable of understanding emotions. As their friendship grows, they embark on a journey to bridge the gap between humans and machines, and you get the point, right? Let's look at another example. On a distant planet, a team of explorers discovers a mysterious artifact that, and then our large language model, our handy, helpful large language model assistant, completes it by saying, grants them the ability to manipulate time. As they navigate the consequences of this newfound power, they uncover ancient secrets and face ethical yada yada, right? So this was just like a brief, fun, little example viewing session, right? We all have given better prompts than this. Instruction tuning is something that is ChatGPT, that's something that ChatGPT stands on. So it's not as simple as, you give a sequence of words and then it has to predict the next word or the next 10 words. ChatGPT and the new models are more sophisticated, where they are instruction tuned models, where you have to do certain things. They don't just have to complete sentences or play a game of fill in the blanks like proposed in the original Transformers model, right? Because the original Transformers model, the whole example which they took was language to language translation. That is, I think it was English to German or something like that. Cool. So when we say the task is to predict next word or next n words, we are inherently introducing the concept of token limits, right? But what if we want the LLM to continuously keep predicting the next word forever? Funnily enough, we don't like when people talk too much, right? But what if we want the LLM to do that? Well, that's not entirely possible as of today with great accuracy. Hence, we do have both input and output limits when it comes down to operating large language models in general. Token limits are required because of various factors like memory and storage constraints. Like also, as the input sequence grows too large, the large language models struggle to maintain accurate understanding of different interactions and relationships between entities and words present inside our input paragraph or document. My, that was a long sentence. That is, in other words, the attention mechanism that we learned is no longer able to keep focused on the most relevant and important parts of the input. As simple as that. That's one of the biggest reasons why we don't use extremely large inputs and extremely large outputs. We don't like that. And that's why ChatGPT has this 4096 token limit. As far as I remember, I should remember it, right? Because I'm actively working in this area. But yeah, we do have token limits, and larger models have larger token limits. For example, GPT-4 has, I think, more than a lakhs token limit, or 65, or I think it's 165,000 or something like that. Cool. And that's what we call, as you can see over here on the slide, attention dilution is what I was just what I just yapped about. Cool. What are the limitations? Speaking of like all of this, all the cool stuff, what are the limitations, as we mentioned, right? Let's look at the most used buzzword, the limitations buzzword, hallucinations. Well, what does hallucination mean? It exactly means what we understand about hallucination in humans. Seeing things which are not, right? That is, the large language model, in this case, instead of our brain, starts making stuff up. At core, large language models ought to output something, and therefore they cannot resist saying something around the topic. What are the causes of hallucinations, right? At its core, hallucinations are largely because the large language model has to perform guesswork or has insufficient details in the input itself, or does not know about it because of the lack of data set on which it is trained, right? Let's look at what types of hallucinations there are. We have factual contradiction. That is when the LLM gives you a gospel false response, which is not correct, which is not a correct fact in the human world. Then we have prompt contradiction, which means you have asked for something and the response that you get says that you should not be asking that, and rather gives you a response for what it thinks your question should have been. You ask one thing, it gives you an answer for the other thing, which it thinks you should have asked, right? You know, something when people want to give you a response on what you have not asked, instead of giving you the response on what you have asked, right? Cool. Let's look at a few examples of the different categories of hallucinations that we spoke about. Let's look at factual contradiction, right? Where we have the input prompt, tell me about the capital of France. The output, the capital of France is Berlin. Wow, right? A factual contradiction. Wrong. It's hallucinated. We can safely say it's hallucinated. Prompt contradiction, right? Input prompt, describe the life cycle of a butterfly. The life cycle does not undergo any, butterflies do not undergo any life cycle changes. Well, it can be categorized under factual contradiction as well. But why we call this prompt contradiction is because you asked it to describe the life cycle. It says it does not have a life cycle, or it does not undergo a life cycle, right? Instead of describing you the life cycle. Next, we have sentence contradiction. Input prompt, write a sentence about the benefits of exercise. Output, regular exercise can lead to improved health, but it has no impact on well-being. The runner's high, the dopamine spike, the release of, what do you call it? Serotonin, oxytocin, which is the stress hormone, which is not the stress hormone, whatever, right? Then we have nonsensical output, which is explain the process of photosynthesis. Photosynthesis is when unicorns dance on rainbows to produce chocolate clouds, right? Such beautiful yet pathetic hallucinations, right? Cool. So, I had planned a break right now. It doesn't read, it reads break, but it's supposed to read coffee break. And if we want, we can take a break. Type yes in the chat if you want a break. Type no in the chat if you want me to continue yapping. We'll return in 5 minutes. All right. You want me to continue? You want a break? Okay. Okay. We have half and half items in the chat. Maybe the administration, can you pitch in? Do we want a break? Do we not want a break? Depends on the audience.
I believe you can take the call, Prathmesh.
Okay,
Yeah.
cool. So let's do one thing. Let's take a 2 minutes break. And because I need a break. And I'll be back in 2 minutes.
Yes, right.
Thank you.
So participants, with just 2 minutes of break, we'll be back again with the session.
All right. Cool. Can we get started again?
Yes, please continue.
Okay. All right. Moving on. I hope everybody had a good short break, and I hope everybody has a cup of coffee with them, or at least it's on their way, and the cup is on its way. Right. Let's get back into our main topic now. Retrieval augmented generation. At its core, RAG is the process of optimizing the output of a large language model so that it refers an authoritative knowledge base outside of its training data sources before generating a response. This is Google's definition, which I just by hearted, or I'm reading at it and telling you, right? Let's break it down a little. What does it mean, right? RAG is the process of optimizing the output. If we look at it, this is the output. We want to optimize that of a large language model. Well, the generator is the large language model that we are talking about, so that it refers to an authoritative knowledge base, which is this, outside of its training data sources. Now, what does outside of its training data sources mean? Remember, I spoke about India Interim Budget 2024, which came out on, pardon me if I'm saying it incorrectly, the first week of Feb, I think. Some first, second, some Feb, right? So does ChatGPT know about this budget? Is ChatGPT trained on the latest data? The answer is no, because ChatGPT went under a rock in January 2022, the last time it was trained. Up till then, it has the information. It might have all the information, but not all, right? It might have missed some news. It might not have something in its training data. The ChatGPT that we all use has some training data at the core of it, right? And that training data is curated by some people, is curated by a lot of people, to be precise. It's like open source work, right? But what if we want our own data, like budget or our own custom, like as professors, when there are notes written down, or there are custom PPTs that professors prepare, all of this is custom data, right? GPT doesn't know about it. And that's where RAG enables that. Well, you might say, hey, hi, why do we need RAG? Why can't we retrain the model? Why can't we do transfer learning and retrain the fag end or the tail end of the network and then customize it to our own data set? Yes, we can. And OpenAI offers that as well. But the cost to retrain a large language model is way larger than retrieval augmented generation. Now, with that said, let's move on to knowing why we need RAG. The obvious answer from what we just learned so far is going to be eliminating hallucinations. Because as we saw, that one of the biggest causes of hallucinations is insufficient training data. And hence, the large language model being hell-bent on giving some output will start hallucinating. And hence, RAG is useful in multiple domains. The place that it is used is at domain knowledge, the places where it is used is domain knowledge transfer, factual accuracy, contextual relevance, reducing bias, misinformation, near eliminating hallucinations, like I mentioned, big data indexing capability without retraining, right? Moving on. Let's take a look at how the retriever looks, right? The retriever has a few components inside it. The data source is, as I was talking, is our original data source or our domain's data source. That data source which ChatGPT does not have, right? We first take that data source, we then chunk that data source into smaller pieces, which is called the process of chunking, right? Once we have the chunks, in parallel, what we do is make sure that we have mapped the chunk to its own parent link inside the original data source or our domain knowledge. Once we do that, we convert the chunks into embeddings using any popular embedding model. What are embeddings? We will look at it just right in the next slide. Once we convert the chunks into embeddings, it will then get fed into the embedding store. And this will be yet another database. And these embedding stores are called, in practicality, vector stores. And these embeddings are called indices, vector indices, right? Once we have our source data chunked, converted into embeddings, and stored in the embedding store, our retriever has now done its job. Our retriever is ready to function, right? Let's now take a look at quickly what are embeddings in the first place, because we yapped about the retriever, but it is all dependent on the logic and the concept of embeddings, right? Embeddings are, simply put, strings or text converted into a vector or a point in space. If we want a two-dimensional point, we typically have two coordinates, that is x, y. If we have another point, we'll have x2, y2, and so on. If we want to convert this string into, if we want to plot this string into a two-dimensional space, we'll come up with some xn, yn. In this case, for the more dimensions you add, if you add a third dimension, you'll have a lot more space to now fit in all the possible sentence of English language, German language, whichever language, like you'll be able to store much more in three dimensions, right? Similarly, if you take the dimension notch a little higher, you can go up to 500, 785, and whatever number of dimensions you want to rise to, right? In order to represent any given piece of text as a point in an n-dimensional space, which we essentially call the vector. And this is the process of embedding, right? Sorry. All right. Let's look at the generator architecture now, which is also the second part of RAG. Now, as a user of ChatGPT or any large language model, we have an input always, which is called the user query, right? In case of ChatGPT, this user query does not go to the embeddings. This user query directly goes to the generator, which is ChatGPT in our case, or in any LLM, which you can say. And then that will give an output according to the base data that it is trained on, right? But in case of a generator in a RAG-based system, the user query first is searched in the embedding store. A piece or a chunk from that is retrieved as context. Let's take an example of India budget. I want to know what is the summary of India budget, or who was the speaker of the India budget, whatever, right? Now, let's say I'm asking who's the speaker. Now, first, this user query, who is the speaker? So now we will first search in our embedding store the word speaker, where all in our original budget PDF we have. And then who is the speak? So the names will come, and we have like this chunk, right, stored inside the embedding store. So everything around that chunk will also come, not just that word. Everything around that chunk will also come from the original paper, right? And that is attached as a piece of context to our user query. So that will look like, hey, ChatGPT, this is my context, what I found in the embeddings store, which is populated by the original data set. And this is my query. What was my original query? Who is the speaker of this? So and so. This will now go to ChatGPT and come back with the output. So to ChatGPT, not only our input query is being sent, but also the context with that is automatically searched for and sent. Retrieval-based augmentation, retrieval augmented generation is all about having a store of knowledge or a knowledge base and retrieving the context of the specific user given query from the knowledge base and then making use of the LLM or ChatGPT to get the real answer to that. So instead of saying, hey, who is the hero in Superman? ChatGPT will give you the hero in Superman is so and so and so. But if you say, hey, I will give you my own story. You say, hey, my own story about Superman is Superman's hero is Arnold Swartz, blah, 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 right? So, or Ronnie Coleman. And then you ask, who's the hero of Superman? ChatGPT will give you that, hey, you have told me according to your story, the hero of Superman is Ronnie Coleman. So ChatGPT will tell you Ronnie Coleman, not the original hero. Why? Because ChatGPT will consider what you have provided first. And then what he knows, or the machine knows already, right? And this is retrieval augmented generation all about. That you have some query, you have some knowledge base, which is your knowledge base. You search in that knowledge base where your query's answer might be. And then you get the bigger chunk because your query, the answer is not going to be there in its form, right? What you're asking. So you have to get like a bit of context, a bigger chunk with yourself, and then give it to ChatGPT. Does that make sense? One quick pause. I'll take a quick pause. Am I making even a tiny bit of sense? If I get a yes, I will get a bit of confidence. Okay. Thank you. All right. Those are a lot of yeses. Thank you so much. Cool. So let's have a look at the bigger picture, right? Just what I explained. You have the original prompt, which is essentially the user question. Rather, you have the original user question. Then you have the proprietary data. You have the embedding model. You have the vector database, which is the embedding store that we talked about. Those are vectors, embeddings are vectors. So this is a vector base or vector database. You search, you attach it, original question, right? The prompt becomes, instead of ChatGPT prompt only the original question, the prompt becomes original question plus the context. Now over here, you can fetch top K relevant documents. That is the top K chunks, right? If you don't want just one chunk, if it finds that word speaker across like 5 places in the entire paper, you have 5 chunks, right, to choose from. Because the word speaker, who is the speaker? That word speaker is across many different chunks in the paper, might be, right? So you have to choose from only one or top K. Then you can define if you want to choose from top K. So the prompt will look like, hey, my top K context look like blah, 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 blah. And then the original question, and then you'll get the answer, right? Cool. So this is essentially in a nutshell how RAG looks like, right? Now the context piece that I'm talking about, right? Giving some context to the large language model so that it refers to what you have given first, right? Your logic first. So let us look at that logic, playing around the logic, right? How does that look? So we have zero shot, few shot, and chain of thought prompting. So let's look at chain of thought prompting, right? Standard prompting. Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? The answer is 11, right? So you are giving some context to the uh, 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 LLM, right? You're giving some context to ChatGPT, saying that this question's answer is 11. Then you ask a similar question, right? The cafeteria has 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? The answer is 27, which is wrong. You don't have to do the math. If you're extremely fast, I envy you, but assume that the answer is wrong in the interest of time, right? Second, chain of thought prompting. Roger has 5 tennis balls. Again, the same question. But this time, instead of saying just the answer is 11 in the prompt, this is a part of the input, right? Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, 5 plus 6 is 11. Remember when we were kids? I mean, I'm still a kid. I consider myself still a kid. But when we all were kids, that time we had marks for steps, especially in mathematics and physics and chemistry and all of that, right? We had marks for steps. So even when you're prompting ChatGPT or any other large language model, if you help the model with some context, then the model will be able to do a better job. This is the basis of retrieval augmented generation. Does it all connect now? All of a sudden, like epiphany, where we just saw that giving ChatGPT more context, telling it, spoon feeding it, instead of relying on it as an input, as a part of the input, works wonders. And then researchers thought that, oh, giving it in the input itself works wonders. Now let's make a system around it so that we are able to refer to huge knowledge bases, SQL databases, SQL databases, NoSQL databases, MongoDB, big databases, PDF documents, Word documents, PowerPoint presentations, whatever you have, big data. We can answer any question around that. Especially, this is handy for businesses to have service desks that can answer questions based on the knowledge bases that are present across the industry. In UBS, when I used to work in UBS, we have in many companies, we have these service desks for internal employees. My PC is not working. I need access to this VPN. I need access to this server. I need to install this software, whatever that might be. You have a service desk where you can call, get the answer, get done with your technical problems so that you can do your job. Especially in giant companies, service desks are a big deal. They are huge service desks. Locations are dedicated for service desks just to help people how to navigate around the company. Now, just to help people, internal employees, how to navigate around the company, you're having to set up locations and locations, right? Instead, RAG says, we have come up with indexing. We have come up with cosine similarity comparisons. We have come up with making use of the beautiful embeddings model to compare your input query in order to fetch the relevant chunks. And then you can choose top K, depending on how big of an input can ChatGPT take. ChatGPT 3.5 Turbo can take 4096 tokens as input. So your chunk size should be a little less than that in order to accommodate your user input also. In that way, if you pick your top N, top K chunks, then essentially you have to fit your input in that stipulated size. There are larger language models like 1 lakh plus tokens where RAG works even more beautifully. You can have top 50 context, right, for ChatGPT to get help with. Essentially, this chain of thought prompting can be as big as possible. The input, the more qualitative the input, of course, the larger the input, the more confused the LLM is. But the fact that the LLM is offering 1 lakh plus token limit, that means OpenAI is pretty confident about it. So we can safely use up all that limit, right? So the accuracy you get with RAG, right? All of this, or else you'll have to type manually, right? But we have RAG to index whatever data you have in your organization, your company, your college, your institution, wherever you are. Cool. I already yapped about the use cases, but the use cases is to essentially chatify websites, company data, SQL, NoSQL databases, research papers, email, stock market, fundamental technical analysis of companies. The stock market fundamental technical analysis piece is really interesting, right? At least for me, it is. Say yes in the chat just to have some interactivity, right? In the session, say yes in the chat if stock market fundamental technical analysis excites you as a use case of RAG. Or say no if it doesn't. That's fine. Maybe it just excites me. Thank you, Guru Raj. Nice to know it excites you. Okay. Okay. Cool. All right. Let's move on. What is the framework landscape of RAG and its frameworks, and what vector databases or the embedding, what kinds of embedding stores do we have? What kinds of integration frameworks do we have? For integration frameworks, we have Dusk, LangChain, Llama Index. For vector databases, we have Deep Lake, Supabase, and V8. I am not familiar with each and every one of them, but this just shows how large of a landscape this is and how impactful of a technology this is, right? In LLMs, RAG and LLMs, we have Azure machine learning. We have Hugging Face, which is the best and the greatest repository for cool machine learning and data science models. RAG frameworks, we have Haystack Farm, Google Realm. It's sort of boring to go through this slide because it's just reading through names and proper nouns, which neither I understand nor you. I don't know about you, but at least I don't understand. Cool. So I had planned another break, but we won't take this break, right? Let's directly jump right into the demo. Before we jump into the demo, let me quickly pause for a moment and know if we all are here and if we can proceed with the demo or if we have any questions. Do we have any questions for now? Okay. Okay. We do not have any questions for now. We can then proceed with the demo. All right. Now, at least, can I get a yes on chat if my VS code is visible to everybody? All right. That is great to know. Perfect. Perfect. Thank you. Thank you. Perfect. Right. Now, let's have a look at few data sets that we have. Did we speak about Indian budget? Yes, we did. Now, Indian budget. I had forgotten the date of that. Remember, it's 1st February. Interim budget, speech of Nirmala Sitharaman, Minister of Finance. And then we have this whole budget of 32 pages, right? Now, what if I quickly want a summary of this budget? What I'll do, I'll spin up a RAG system, right? A micro RAG system that I quickly spun up. Let's go through what we are looking at, right? Here, our base data is this PDF file, right? Once we have this PDF file, what we want is to create an embedding store as per, remember our, I'll quickly go back to the retriever, right? All can see my retriever screen, right? Over here, we mentioned that we will, from the source data, this is our PDF, the budget PDF we are looking at, folks. This is our source PDF, right? And this is our embedding store. At the end, we want this embedding store, right? Now, because of libraries, because of frameworks, things become really easy to get started with. Now, if you want to do something really complex and really cool, of course, that takes time. But to start with, the libraries make it very easy to get this embedding store from this source data. All right. Now, let's have a look at how this relates to, right? Now, over here, we are getting the index where we are loading the documents here, which is simple directory reader data source. We are loading the document that I have mentioned, right? When we will use this data source, right? This is a function. It has a parameter data source. So we are reading that source data. In this case, we will be testing it on India Budget 2024 PDF, right? So that is our source data. Then we are converting it into a vector store, right? Now this vector store is called index in our case, right? Or vector store index. Index is because we can refer to that very quickly, right? We typically index something, essentially hashing or something like that, right? So it is a vector store index. So essentially the embedding store that we were talking about. It is that, right? Once we have that, we are using that vector store index to get a query engine. Now, what is this query engine? Let's go back to the generator. This query engine is this generator. It's not directly the foundational model, right? It's not directly ChatGPT. It's a custom generator, which is the query engine, which is going to make use of our index, which is our vector store index, right? Once we once we load the query engine, we query that query engine on this line where I'm highlighting. We query that query engine with our custom query. A lot of query, right? A lot of times did I say the word query, but it will, I'll skip that word, to the large language model, right? Cool. So now let's have a look at it in action, right? Let's okay. Cool. So our data set, like we are mentioning, query with RAG, this function takes two parameters or two arguments in this case. To be precise with the difference between parameters and arguments, it takes two arguments while we are calling it. It takes a data source and it takes a query, right? So what is our data source? Our data source is our India budget. It takes a query. What is our query? Our query is summarize the reason. Oh, sorry. Our query is summarize the budget, right? Do we have chat? Yeah. Okay. Now we have summarized the budget, right? Let us now run this query, right? Let me move myself away. I will restart this environment just to be very clean. I will move myself back in place. Cool. Let us run the first cell. It's a function, nothing really great happening inside it. Now we run the second cell where we say, thank you so much, Mrs. Jyoti, Prahlad Patil, and Dr. Vijaya Lakshmi. Thank you so much. That gives me a lot of confidence. Cool. Now, while I said thank you, we have successfully implemented the query and we have gotten the response from the RAG system, mini RAG system that we have built right now, right? Over here, I have just printed out a small information when we are loading the query engine because that's a little heavy. I'll explain this piece of code a little later. This is where if we already have the embedding store generated, we can skip regenerating the embedding store by rereading the PDF. We can skip that and load it on from the disk itself. So depending irrespective of whatever is happening, I've just written a small information over here, which is which we can essentially ignore. And then as a response, we have the budget speech provides an overview of the government's efforts to mend the economy and put governance systems in order. It highlights the successful steps taken to attract investments, implement reforms, and achieve yada, 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 yada. Right? Now, let us do one thing so that we know we are not doing foolery or magic, right? As promised, right? Let us go to ChatGPT. And what was our query again? Our query was summarize the budget. Now, in our query, we did not even bother summarize the Indian budget, whatever. We didn't even bother doing that. right? We just said summarize the budget, but of course, I mean, let's, if I just give summarize the budget, it's going to ask me what budget, right? So we all know that it won't give an answer, right? So let's be a little more specific, right? In the interest of time, we all know summarize the budget. It's not going to be, it's going to ask what budget, right? Or else let's just try that. I'm sorry, but I don't know exactly, right? Ask what budget, right? So let's make another chat just to keep things clean, right? Now, summarize the budget. Summarize the India 2024 budget that came out in on 1st Feb. You see, already I'm having to give it such a longer text and much more information that I gave to RAG, to our little RAG system. Let's look at what it says. I am sorry for any confusion, but I cannot provide real-time information or updates beyond my last training data in January 2022. Therefore, I do not have blah, 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 blah. In a sense, ChatGPT is trying to tell us that it has gone under a rock after January of 2022, and it does not know anything. And of course, proprietary company data, proprietary whatever data, even the notes that we make, right, that students make or whatever, it won't know. Retraining, is it an option? Yes. Is it costly? Yes. Does it take time? Yes. Is RAG an option? Yes. Is it efficient? Very much. Is it cost effective? Extremely. Is it fast? No doubt about it. As fast as the compute engine, right? Cool. Now, let's take another look at a very interesting example. Let's take another example. Now, I am a professor, right? I am browsing ArcZiv and I want to see, hey, what's up in the space? What are the new research papers that have come out? So I click on new, I go to new computer science, yada, yada, yada. Now, this is new submissions, Monday, 12th Feb. Wow. Today's submission on ArcZiv, right? Now, we say, of course. Now, do we all believe? Do we need to ask ChatGPT, tell me about this paper? What will ChatGPT say? I have gone under a rock. Do we all agree? Just for a quick check, right? Just for a quick check, Copilot is giving answer. Okay, Copilot is giving answer using ChatGPT 4. Yes, yes, using ChatGPT 4. You can get the answer using ChatGPT 4, and ChatGPT 4 exactly uses RAG internally as well. Right? We are looking at a system which is internally implemented with RAG, right? Because you can on ChatGPT 4 give it a PDF, ChatGPT 4 Vision, right? ChatGPT 4 Vision works with image inputs as well. However, a RAG system is capable of much more that ChatGPT can give you out of the box. A RAG system can connect to databases. A RAG system can connect to TBs and petabytes of data and be able to effectively search and get the right top K relevant context in order to aid your query in the most effective fashion. I don't know. I haven't used Chat GPT 4. I have used, I mean, I to implement this system, right? OpenAI subscription is required. So I am using the OpenAI APIs, but Gururaj, on ChatGPT, can we connect ChatGPT to like a database or something like to handle use data, or is it one by one PDF? Okay. In my opinion, it is one by one PDF, but RAG can work with one by one PDF as well as Copilot. Yes. Okay. Copilot is, you're talking about GitHub Copilot, right? GitHub Copilot, right? Microsoft. Okay. Okay, that's fine. They even Microsoft might be making use of some technology in them, and we are having a look at RAG in terms of the technical lens. Of course, there are multiple products. Of course, we are not talking about any specific product, but we are talking about the underlying technology that goes inside that product, right? So multiple such products are there. We have uh, adding extension, we can make ChatGPT internet enabled. Yes, we can make ChatGPT internet enabled. Google Bard is one of the internet enabled LLMs, right? So they all make use of this technology at their core. They might be making use of different technologies as well. However, one of the technologies that can be used to exactly solve this purpose, chatify websites, extension, web chat, right? Then chatifying databases, chatifying virtually a lot of things. This is one of the very, very strong technical solutions that has become widely famous in the market and is being used by a lot and lot of companies. It's being used in the pharmaceutical space, for example, in the new research space of clinical papers and clinical trials. Whatever they have to follow the GXP good practices, right? So it's used at a lot of places where there are huge knowledge bases and you have to query them essentially. Cool. So let's have a look at this, right? I am reading a research paper, right? And I'm going through a research paper and I don't want to read this entire research paper. I only want to get a gist of this research paper, right? Now, I'll quickly download this research paper. I will quickly paste it, right? Let us say I pasted it over here, uncertainty awareness of LLMs, right? This is the same research paper. I've just prepared it over here, right? Now, let's change the input. We change the input to uncertainty awareness LLM, and we say summarize the research paper, right? Over here, I'm going to show you an interesting example where even RAG finds it difficult to get an accurate answer. I'll tell you how. Now, let's say the we change the input to uncertainty, this research paper, right? What we have, and we ask it to summarize the research paper. Now, let's see what it responds with. Now, for this as well, our data store or our embedding store is already built. Therefore, it loaded fairly quickly. Now, once we get the response, the research paper presents a comprehensive study on the effectiveness of probabilistic methods in improving the prediction quality of code L Llama, a language modeling system for code generation, blah, 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 blah. Now you will get this response and get a gist of the research paper that you wanted to read, right? And then you say, hey, this looks nice. And then you go back to the research paper. And then you read a little more about it, right? Uncertainty, calibration, quality. Let's say you're reading, predictions of performance, uncertainty, calibration, quality, right? So let's say you want to ask the system, hey, elaborate a little, explain what is uncertainty, calibration, quality, right? So let's ask it to do that. Explain what is. I have no idea why it is. Okay. Right. Now let's try asking the question again. It takes a little bit of time. This query actually goes to OpenAI using the OpenAI API that it uses internally. I have the key loaded in my system, so there is no site of the private key that I have loaded in the system is loaded in the environment variable itself. So this code runs flawlessly for me once you have that environment variable set for that key. Seems like it is struggling a little for this one, or my little MacBook is struggling with this output. Am I still visible? My internet is fine, right? I think it's my MacBook that is struggling.
Yes, yes, it is visible.
Yeah. Okay, let's try and interrupt that. Let's try and restart the kernel and let us try and run all again. Perfect. Uncertainty calibration quality refers to the accuracy and reliability of a predictive model's estimation of uncertainty. It is important for a model to properly quantify blah, 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 right? Now let us have a look at if the research paper talks about the same thing, right? So first we compare accuracy, different models, right? So maybe it has given like a definition of what is uncertainty calibration quality, but it has certainly looked at this research paper and given it with in context of this research paper, right? What they are doing over here in context with that thing. Or maybe it has simply explained because I asked it to explain. So let's have a look at one problem that we might observe while doing this, right? Let's say benchmark code data sets, right? Let's say I'm again reading through the research paper and I see that, hey, benchmark code data sets, right? So let us say I want to ask, what were the benchmark code data sets used, right? What data sets were used for benchmark code, whatever, right? Whatever that means, what data sets were used. I want to use that, ask that, right? So let's say I ask this question again. It gives me Codex Glue and Big Clone Eval were the benchmark code datasets used. Is this correct? Let's try to see, right? Let's copy this word. Let's search it over here. Codex Glue, a machine learning benchmark dataset for code understanding. But do you observe what section of the paper this word is found in? It is found in references. Of course, I don't want to bother myself with what dataset was used in this paper. I, of course, want to know what dataset is like in the referred paper, of course. I don't want to know what dataset was used in Shuai, Lu, Daya, this specific paper, right? I don't want to know that. I want to know only that was used in this paper, in the paper that talks about uncertainty awareness of large language models under code distributions if the benchmark study, right? I want to know what data sets were used in this paper, not from something from the references, right? So this is one of the limitations of RAG, where if you have unclean data, any machine learning model is as good as the quality of the data set it has at its core. Now, over here, you have to make sure as an engineer, if you're working on it, by you, I don't mean you, but the engineer or person working on this has to make sure that such anomalies are taken care of, where you're not, where you're limiting your search to relevant spaces. Or you can increase your top K. If you increase your top K, you might have more results. In order to increase top K, there are a few parameters that you can set, and accordingly, you can increase top K. So essentially, the library that we are using is called Llama Index, right? So anytime, like our professors taught us, anytime you want to know about something, type the thing's name and documentation ahead of it, right? So we still do that. I still do that till date. So this is the library that I demoed this using. And in this library, of course, you can explore many more concepts of the loading stage, what all can you do, the connectors, what are nodes, what are documents. The connectors are especially very proficient at reading from several databases. If you go, they say you go through Llama Hub and you have all these integrations. So if you are a company, you have the database integrator, you have Notion. Notion is a note-taking application, PPTX, JSON, Google Docs, Markdown, DocX, PDF, unstructured. You have this is a hub. This is where anyone can contribute. This is an open source hub. So essentially, you can use so many loaders in order to perform RAG on. With this said, I would like to take a quick pause and ask the audience if any one of you wants any one of your document, or you can tell me what you want me to search on Google. Let's download that PDF and let's ask a question to it. If there is anything that you want to get addressed, or do you want to try it on something that you want? I gave an example on this research paper. I gave an example on the budget. I had an example for a 10th standard science book also, but then just 15 minutes before the session started, I was like, okay, I have to omit the 10th standard textbook and I have to bring in like a research paper, right? So do you have something in mind on which we can load here and we can try asking that onto this, and we can, play around with the technology, or we can open up for questions. With that said, my piece of information that I had to gladly convey today in this session is over at this point. And I need a sip of my very cold coffee for my very dry throat through the speaking. But document containing images. Okay. Okay. So I do have a document containing images. Let's look at this. The human eye. This has images. Do you think this has images? Dr. Kavita? Is this document okay? Text in the images. Okay. Okay. So for that, we can try asking recombination of the spectrum of white light. So I can give you an example of text in images not using RAG, but I can certainly give you an example of that. I will quickly show that to you. Yeah, query on images. I will quickly show how we can query on images. Yeah. Okay. Cool. So let's look at this, right? Here I am using let me get this out here. Right. So here I'm using this data set as a question paper, right? Wait. Data engineering, extracted images, question paper, right? This is the question paper that we are looking at, right? Is this okay, or do you still feel this is not an image and this is this thing? Do you still feel this is not an image? Is this very cleanly organized, or do we want to do it on this one? Is this okay, handwriting? And Dr. Kavita? Handwriting, right? Answer sheet. Okay. So let's do that. Let's do it on answer sheet, right? Example with number plate. Okay, is this okay? This answer sheet is okay. It is like almost handwritten, or it is handwritten, actually handwritten. I think this should be fine, right? Okay. So let's take this example. So, let us okay. So I have it already executed here. So we can quickly go over what text was extracted, right? This piece of code, I'll try to go over it quickly. This is an answer sheet that is submitted by a student. So let me give you a brief background. This is what we do at Adelaide. This is I'm a co-founder of at Adelaide, which is a 1-year-old educational yada yada yada, the thing that I introduced in the beginning. So we are working on this to enable institutions and schools to check and assess handwritten answer sheets. The assessment model is a big, elaborate, much more sophisticated model, but this is a small demo of extracting handwritten text, right? Very precisely. So this is the input sheet that we have, right? Now, we are using GPT-4 Vision as is provided by OpenAI in order to perform this. So as an input, we say extract all the text and output in JSON, right? Format, which is extracted text, colon, and string. Then we give the image URL in base 64 encoded format. This is just one detail which can be overlooked on. Assume that we are sending the image URL, right? The image as is. Now, max tokens again are 4096, right? The response that we get in JSON. This is the response that we get, right? Now, let's try to see, over here, it is really shabby, right? It does not really look that great over here. Let us go to ChatGPT. And let us ask ChatGPT, just repeat what I pasted, right? Because it doesn't look good over there, right? But ChatGPT will just repeat to us. Okay. Now, it essentially formatted it really nicely for us to look at. And we can copy this and we can go back to VS Code. We can try to format this document, which is already formatted. And we can try to search for, let me move myself away. Let us search for \n and replace that with a enter symbol. No. No. We don't replace that with an enter symbol. With the carriage letter? No. Okay, I think I know what I have to do. Cool. Python for engineers, right? So let's compare this with the original right? So Python for engineers on 3 different lines, right? Python for engineers on 3 different lines. I just replaced the \n with enter, remember? So then it also accurately outputs the sequence, right? It is on 3 different lines, hence 3 different lines. And assignment 1, then we have so and so. Then we have the name of the student, right? Then we have bitwise operators, which is these operators and so on, which is essentially cut, right? So then explain bitwise operator, membership operator, identity. Let me move myself away. Membership operator, identity operator with example in detail, bitwise operator. These operators work on bits and perform all, blah, blah, blah. These operators work on bits and perform all functions bit by bit. These operators, blah, blah, blah. Even these small nifty details, right? Like the tilde, I don't know what it is called, right? But this small little detail also at the very bottom of the page, right? Tilde A is equal to exact number of zeros and exact number of ones, right? 4 zeros and double ones at the start and the end, right? And is equal to -61. Even the minus sign is precisely detected. So this is RAG. This is not RAG. This is GPT-4 Vision. RAG would be when you would use a catalog, which we do at Adelaide essentially, which when we use a catalog of such answer sheets in order to then query and catalog of the original syllabus in order to compare and evaluate answer sheets which are handwritten. So through an example, thank you so much, Dr. Kavitha, for prompting me an example where you wanted me to read text and images. That's how I got an opportunity to showcase what we are doing at Adelaide itself. Thank you so much for that. But yes, this is also very quite possible and very, very accurately, right? So, right. And this is essentially what we do at Adelaide is intended to be used at B2B organizations where institutes, education institutes primarily, because we are an edtech company focused at blah, blah, blah. Anyway, not here to publicize Adelaide, but thank you. Cool. So that is the end of my yeah. Do we have any questions? We have 13 more minutes left.
Any questions from participant?
I encourage the participants to ask any questions. It was indeed a great session, Prathmesh. I could learn so much.
Thank you, ma'am. ChatGPT 4 is not free. But I am honestly using I have to minimize myself again. So I'm using, sorry, I maximize myself too much. Open AI, right? I'm using a key in order to be able to run whatever I ran today, right? Even if I give you the source code, given that you have the key set up already in the system, it will run as it is, right? So these are the API keys that we have here created for each of our essentially folks that we are working with, right? So these keys, given that these keys are there, and of course, using each and every call, even the demo that we did today, right? This also costed a little tiny bit of money, but that's fine. But yeah, using the actual interface of ChatGPT, that takes money. Yeah, that's way costlier. There's $20 per month or something like that in my. Somebody raised a hand. Rushikesh Jadhav. Jadhav. Rushikesh, you have a question? you are unable to unmute. Ma'am, Rushikesh is unable to. Thank you so much, everybody. Thank you so much for attending. I really appreciate your responsiveness. I really appreciate the support.
Hello, Prathmesh sir. Am I audible?
Yes, you are audible.
Okay, sir. My question is not about our session, but for a job profile. May I ask here?
Rushikesh, can you come again?
Actually, my question is not about today's session, but about the job portfolio with respect to LLMs. So can I ask here?
Oh, so the job portfolio. Yes, I mean, what more about the job portfolio? I mean, you're looking at what all types of jobs there are in with respect to LLM as the technology, or how?
Actually, sir, I have civil engineer background, and
Uh-huh.
I want to do a transition of my career within data science.
Okay.
So, I have experience of almost 7+ years in on-site as well as in a teaching field. So, with respect to that, I have completed a couple of certifications of IBM. Yet, during job search, they are giving much importance to generative AI and LLMs, as you mentioned. So with respect to that, I just want to ask, what should do for a core search to get a job in data science field as a career transition?
I might have an answer to that, Rushikesh, but right now, in the context of the presentation, at least I don't have an answer on the top of my mind, and it might be a little unfair. Okay. So it might be a little unfair to be giving the answer to that question in today's conversation context. But yes, LLMs, no, so depending on which domain side you look at it from, whether it is technical or non-technical, whether it is prompt engineering or writing and engineering, machine learning engineering, right? So depending on that, you can take a call about which niche you want to get into, right?
Actually, so I have completed a certification related prompt engineering also. It was
Rishikesh,
actually
one thing, I don't think it is relevant in the context of this conversation.
okay.
Just
Okay.
as an input from your side, you may please continue to complete your question, but just an input from my side. I'm sorry to interrupt, but yeah.
No. Thank you, sir. Thank you for your session. Have a nice day. Have a nice day. Thank you all.
Prathmesh, there is one more question from Gururaj, around 350. He says LLMs can present false information out of date responses. How can it be answered in RH?
Yes.
That.
So with that respect, I will quickly go back to the hallucination. This is something that you're talking about, right? LLMs can present false information, Gururaj. That is out of date, and how is it managed in RAG, right? Right. So, Gururaj, the main intent of preventing or the main observation of scientists to prevent hallucinations, they discovered, like people discovered, that giving chain of thought prompting, where you are providing additional information to the large language model, can help the large language model to reduce the false information that it gives. Right? So people realize that, hey, if we give more information to the model, if we give some supportive information along with our question, if we give some context to our model, then that model is able to give a better answer. It is able to do a better job. Then came into existence RAG. People said, now, will you actually be able to fetch from 1 lakh documents as a supportive material yourself as a human? Probably not. But the underlying principle of RAG is give more information along with your input as context and get a precise answer back. But to feed more information along with the input question, it's not humanly possible to always do that if you have 1 lakh documents. So you have, but you want to add some quality information with your input. That is where RAG comes into picture. RAG is awesome at indexing. Your input query, it fetches the relevant context, top K contexts, and you can feed that to the LLM. Does that make sense? Perfect, Gurudas. Thanks for your question.
My sincere thanks to Mr. Prathmesh.
Thank you.
In short, I want to summarize today's session. Mr. Prathmesh started with a point, that is, what is traditional neural network versus transformer model. He also explained in detail the transformer architecture in detail. Then he focused on some topics like what is a multi-head attention, what is a scale dot product attention, and later on he jumped on a main topic, that is what is generative AI, and explained with some real-time example. He also covered some points like RAG model, that is Retrieval Augmented Generation. What is the need of the RAG model, RAG architecture, zero shot, few shot, RAG application with use cases, and what is a framework landscape in RAG. And lastly, give a live demo on generative AI with some database like Indian budget, how to extract the information from images, and so on. So thank you, Prathamesh. I would like to express my sincere thanks. Your expertise and insights have truly enriched our knowledge and inspired us. On behalf of the AIDS department, I extend my thanks for your engaging and enlightening presentation. We appreciate your valuable contribution for today's faculty development program. Thank you so much. Thank you, Prathamesh.
Thank you.
I also thanks to our organizational team, and special thanks to all the participants for patiently attending the program. Thank you all. Thank you so much. I officially conclude the today's session. Now we will meet again tomorrow with some another interesting topic. Thank you all.
Thank you. Have a great day ahead.
Yeah.
Thank you, Prathmesh sir. It's really a very good session.
Thank you. Thank you so much.
I request all the participants, please fill the attendance that already posted on the chat box.
I also hope everybody, it was not a boring session. I tried to make it interesting as much as possible. I tried to keep it engaging. It was a lot to take in, I'm sure, but I hope it was not. I hope I was doing a better job at keeping you awake than your lunch was doing a better than your lunch trying to make you sleep.
Actually, it's really very interesting session. No one bored. It's really very informative.
Thank you. I see Shivanand, you have a question, which is a website for summarizing this article. Let me quickly send you a website for summarizing this article. I recently came across one. I hope I find it in time. Let me quickly check.